Hi, my name is Bahadur Akhmedov. Welcome to the course of Probability and Statistics. In this video lecture, we're going to discuss about the conditional probability. If you remember previously, we talked about the multiplication rule, where we were interested to find the probability of A and B. In a context that A is going to happen in the first trial and B is going to happen in the second trial. We say that in order to find this probability, we need to find the probability of the A, then we need to find the probability of the B, then we need to multiply this. So, and actually this formula is not complete because we're talking about, say, this formula works only when A and B are independent. So in a moment, I'm going to explain you what does it mean. So let's say we have a box with the balls. And for example, you've got 3 yellow balls there and 2 pink balls. So what I want is, I would like to find so let's say A is going to be choosing a yellow ball, and B is going to be choosing a pink ball. So what I want is, I would like to find out the probability of choosing a yellow one in the first trial, and then choosing a pink one in the second trial. So as we discussed before, it is going to be equal to the multiplication of the probability of the A to the probability of the B. So probability of the A is going to be equal to the 3 over 5. And the probability of the B is going to be equal to the 2 over 5. It's going to be equal to the 6 over 25. But the problem is, it really depends on whether you put the ball back to the box after the first trial or not. So basically, I mean that if you have the box with the 3 balls, so probability that you are going to choose a yellow ball in the first trial is going to be equal to 3 over 5. But, so let's assume that in the first trial, you've got the yellow ball. Now, inside the box, you are going to have only 2 yellow balls and 2 pink balls. And the probability of choosing a B, when you know that A has already happened, you have already chosen the A, is going to be equal to 2 over 4, not 2 over 5 as it was before, right? So it appears we need to introduce the new type of the notation for the probability, where it takes into the account that some event has already happened. So in this case, this notation means the probability of B when the A is already happened. And this notation is called the conditional probability. So this is called the conditional probability. And it appears, if I would like to find the probability of A happens in the first trial, then B happens in the second trial, I need to multiply the probability of the A to the probability of the B when A is already happened. So basically, probability of the A and B is equal to the probability of the A happening in the first trial as it was here. So I wanted to choose a yellow ball in the first trial and choose a pink ball in the second trial. It's going to be multiplication of the probability of choosing a yellow ball in the first trial multiplied as the probability of choosing a pink ball in the second trial, where we know that in the first time we have already chosen the yellow one. In this case, it's going to be equal to the 3 over 5 times 2 over 4. So this is going to be equal to the 6 over 20. So you see, so for the same or similar problems, we're getting 2 different answers, and the reason why we're taking 2 different answers in the experiment types. In the first experiment, we choose a ball, then we put this ball back to the box and choose the second ball. While here in the second experiment, we choose a ball, but we don't put this back. And obviously, whenever we choose the second ball, the conditions are going to change, right? So in this case, we say that the A and B are dependent if the occurrence of the A changes the probability of the occurrence of the B. So basically, if A happens, then the probability of choosing the B is going to change. So I'm going to show you a couple of more examples about the conditional probability. So let's say I would like to make the two events. One event L is going to be all the months, all the long months, all long months. So we have January, March, May, July, August, October, and December. So at the same time, I would like to create another event. R is going to be months with the letter R. So months with the letter R. So they are January, February, March, April, September, October, November, and December. So what I want is, I would like to find the probability of, so let's assume that if you choose one person randomly in a street, what is the probability that he was born in the long months? So in order to find this, we need to count the number of the items inside the L, right? So it's going to be 1, 2, 3, 4, 5, 6, 7. So, and we have to divide the 7 to the 12 because in total there are 12 months, right? So any person which you met at the street might born in one of the 12 months, and the probability that he was born in one of the long months is going to be equal to the 7 over 12. And so what is the probability that this person which you met in the street was born in one of the months with the letter R? So the probability that he was born in the months with the letter R is going to be equal to the number of the months with the letter R, which are 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be equal to the 8 over 12. So now what I want is, I would like to make the problem a little bit differently. So let's assume that you met a person on a street. Let's assume that you met a person on a street and you know that he was born in the long months, and you know that he was born in the long months, right? What does it mean? It means that you know that he was born either in January, either in March, either in May, July, August, October, or December. So what you want is, you would like to know what is the probability that he was born in the months with the letter R. So in order to do this, what we have to do is, we are not going to now. So now our sample space. So before, when you met a person randomly, the sample space contained 12 months, right? So you don't know this person, and he might be born in one of the 12 months. Now, you know that this person was born in the long months. It means that the sample space contains only 7 months, right? So 7, one of the long months. So what we need to know is, we need to know which of these months are the long months. So they are, are the months with the letter R. So the January have the letter R, March have the letter R, July, August, October, and December have the letter R. So what is the probability that he was born in one of these months? So probability this person was born in the month with the letter R. If we know that he was born in the long months, is going to be equal to the 4 over 7, right? Because our sample space now contains only 7 months. So we know that he was born in one of the 7 months. And if I would like to know what is the probability that he was born in the months with the letter R, I have to count the months with the letter R in our sample space and divide it to the size of the sample space. In this case, it's going to be 4 over 7. So please note that this is going to be different than finding out the probability of a person who was born in the long months and in the months with the letter R. So in that case, it's going to be 3. It's going to be simply 1 over 3. So I'm going to explain you what I mean. So the probability that a person is going to be born in the months in the long months and in the months with the letter R is going to be equal to the 4 over 12. Because so there are 4 months: January, March, December, three months which are in both of the 4 months, sorry. So there are 4 months which are in both of the sets, right? So that is why if I would like to find the probability that a person who was born in the long months and in the months with the letter R, what I have to do is I need to find the intersection between these two sets. So in the intersection means the number of the months which are going to participate in both of the sets. So there are 4 months which are participating in both of the events, right? So if this is divided to the number of the months in total, it's going to be equal to the 4 over 12. So at the same time, probability that a person was born in the months with the letter R, given the information that we know that he was born in one of the long months, is going to be equal to the 4 over 7. You see, so there are 2 different values, even though so the meaning might be very much similar. So this is the conditional probability. In our next lectures, we're going to discuss about so-called Bayes theorem, which is going to help us to find the conditional probabilities.